Okay, welcome back. We're at video 2 of the series. This is going to be the intermediate topics. Now, the intermediate topics is going to span several videos, so you'll see the number on my YouTube channel. Just follow them 1, 2, 3, 4. But today we're going to talk about basic class functions, things you can do with classes. We'll have some in object inheritance topics we'll cover, and just a couple little nuggets of information as we go through it. Again, I want to stress this is not meant to cover all the aspects of C#, just things we do a lot. And the source code is available for free. For non-commercial use, you can get it at the link shown here with the login and password shown here. Feel free to modify it, play with it on your own, but you won't be able to check it back in source control. Okay, so let's get right into it to keep it time down. If you'll remember from last time, we have this program file over here. This is where the console application goes by default to execute itself. And you'll notice I've done a little bit different setup on it here. I just thought this would be cleaner as we went through it. The main function, not everything is there anymore. I simply create a new class program and I call the function that I want to run. Like simple topics, if you wanted to run your simple topics example again, you just remove these two marks and it would run. I guess I could show you. And this should all be familiar. You'll see that color. I change a color too, just so that if they get crossed, we know which one's running. So that's how you can run your simple topics if you still want to run them. But we're not here to run the simple topics. We're here to run the intermediate topics. So we will go here. And I'm going to go ahead and run it. And that way as we go through it, we'll kind of see what's going on. You'll have a point of reference. So I'm going to go here, debug, start without debugging. And so basically what we do is we create three classes, employee, human, and person. And then they're obviously going to inherit from each other. And I'll explain what that is in a minute. And then we just put what's in each one out on the screen. Not too complicated, but good for video too. So how do we do that? How do we do it? Well, classes, as I said, were a combination of data storage and functions that can execute code. But let me give you a scenario that we run into a lot in computer programming. It's where you've got an item or several items that have commonalities in them. Let's say you've got employees, contractors, things like that. Well, they're going to have some things in common, whereas an employee, maybe they're a full-time employee, they're all going to have a first name, middle name, last name, worker's ID number, whether they're male or female, things like that. And they're also all human, we would think. And the only thing that would vary would be things specific to a contractor. You might have a length of contract field or something like that that you wouldn't have on the employee. So I thought that made sense here to use an example. A lot of times I see people use for OOP, object-oriented programming, they use banking account examples and things like that. And not to throw them under the bus here, but our government and a lot of our citizens don't seem to understand banking. So I'm not going to use that. I'm going to use people, and we're going to just kind of go through it with the employee example I gave you. So let's think about it before we look at it. I told you that every employee in most companies, I know there's dogs out there that work, but they're going to be human, right? And humans all have some traits in common, and one is we have a heartbeat or we don't, right? Then employees are also people. People have names. People have various IDs, things like that. We're not going to put everything in our person class. It would simply be too long. And then we have employees, and employees have what? ID numbers, right? And they have whether or not they're a current employee. They could have join dates, various other things, pay rates. That's not all here, just a few to keep it short, a few things, and to leave some improvement for you to do. I haven't put it all here. So if we think about it, we can say, well, okay, think about it as tree. I love to use a tree analogy. The base of the tree is human, right? Because they all share the traits of human. And then if you moved up one level, what's the next one? It would be a person, right? So a person has everything that a human has, plus vertically it has everything a person has. And then we want employee, right? So you got more branches higher up the tree. Employees. Employees have everything that employees have, plus everything that what? A person has, plus everything that a human has. Right? So it's not, when you think about it conceptually, it's not hard to understand. And when we put it in code, it's not much harder to code. Some people like to make it sound like it is, but it's not. So we're going to bring up the class on here, the intermediate topics. Now, you'll notice I don't have, like I did on the simple topics, a class dedicated to each human, person, employee. I certainly could, but to keep it easier for you, what I've done is I've gone in here and created a class, the intermediate topics, just like we did on the simple tasks. What we have is 3 classes here. We've got human, like we talked about. It has a constructor. Remember I told you every class has a constructor. It tells it what to do with itself when it's created. It has some member variables here, and we'll see that they got the private by default, and then we got them public so you can get to it whether or not the heart is beating. You heard me mention that. And then we've got some code we can execute. We create a new human, we simply turn the heartbeat on. And when a human passes, the heartbeat is false. And notice the class declaration up here, just public class human. Now if you want to inherit from this class, and what that means is get everything this class has in your class, it's not too hard to do, and I'm going to leave them both up here on the screen. You'll notice I have another class down here called public class person colon human. So what that means is that person inherits all the properties and behaviors of humans. Now you can do a lot of things with this. We're just going to cover the basics here. But just understand that person, just by doing this, is going to have what? Heartbeat. Plus everything else is public. It's going to have a ability to create a new human, and human passes. But what it does is it goes through the human class to get that. Don't think that it copies the code down here for you. That's not what happens. The compiler is smart enough to know that this human class up here, if you do something through the person that actually calls a class or a function, or not, sorry, not a class, a function in the human class, it'll go there to get it. But you'll notice on the person, our constructors get a little bit different. On the human, if I scroll up, we had an empty constructor, no parameters. We just turned the heartbeat on, creating a new human. Turn the heartbeat on. And then on person, you've got to send it the name and age of the person you want to create. There's no empty constructor. Because I defined one with parameters, remember I told you get one for free? Well, that's only if you don't define any. Here I did. I defined one with 2 variables. And so you're not going to get the empty one. So when you, unless you define it like I did here, but if I had just done this, you would have to always send the name and the age. But in this case, I provided an empty one, which is always a good idea, and I just set the variables in here to their default values, right? And I call base.createHuman. Well, what is a base class? Well, the base class is the class we inherited home, this human. Okay? So it's just going to say human dot create human, which turns a heartbeat on. Notice I didn't say human equals new human or any of that, just base dot create human. We inherited from it, we can make calls to it through the base. Now we're going to do something cooler in a minute, but this is just a basic way to do it when you're not sending any variables. So I told you that a person has an age, which we know how to do these declarations, and it also has a name, right? And just for kicks, I stuck one in here that every human is taxable in this country anyway, so they're taxable. And then the functions is we can celebrate a birthday, and that just adds 1 to the age, or we can adjust their age because, you know, you put people in the system, you make mistakes, so we allow ourselves to edit the age. So let's think about what happens. If we create a person class, what does it do? Well, it's also going to create a human class, right? And which one is it creating? From the empty constructor. So if we want to trace that back, where's the empty constructor? Right here. So it's going to do everything in its own constructor, then it's going to run this code. It's going to do all this, then it's going to run this code. Fair enough? That's not hard. Now, I said we move up to the third layer on the tree, and it was an employee. Well, an employee has an ID and whether or not they're a current employee. Now, you can add a lot of different fields in here for employees, but I want to keep it short. But if we look up at the top, you'll see that we aren't deriving from human anymore. We're deriving from person. Well, it's really cool that we get everything person has, and person has everything human has already. Right? So that makes sense. We're good to go. So we're going to get a heartbeat just because we got everything a person has. So let's look at the constructor. The constructor for an employee is quite a bit more complicated, and the reason is that I didn't want you to be able to create an employee without the basic human traits and without the basic person traits. So I just said you have to send the age, the name, the employee ID, and whether or not they're a current employee. This allows them to create records for employees that may have already quit. Maybe they're upgrading to the system. Every time you do design, you need to keep that in mind. So what does this do? This creates an employee, but this is different. What it does is, and what this is saying is, call the base constructor that takes a variable of type string, and in this case, send it the name, and a type int, in this case, send it age. You'll notice before, up here, if I can find it here, we didn't do that. We just did the create new human. But here, in the constructor, we can call the constructor on the base class that we want to send data to. Right? Not a big deal. So I just wanted to show you a different way to do it. This is the way I always do it. Or I guess I should say 90% of the time. No programmer does the same thing all the time. But 90% of the time is the way I do it. Just, it's cleaner, it's neater. And there's some things, and there's reasons you wouldn't just say, well, Dean, why wouldn't you just say, in this case, I could go in here, and remember I said we have a name, right? So I could go in here and say name, right, equals name. Because we get everything that the base class person has, so we can get right to its name property. Well, this is a bad idea because there's some things that you can do in a constructor that you can't do anywhere else. An example of that is a constant. I didn't go over those in the basic because, like I said, I assumed you knew what a constant was. But you can't initialize a constant anywhere but when a class is created in the constructor or something like that. So I always like to do whatever base work I need to do in the constructor. Default values. This comes from my CSLA experience when you've used factory methods to do things, which we're not doing here. But you have to at least know where your default values need to come from, because it's very possible you need to reach out to a database to get some of these values. Alright, and yes, we will have a basic database example in time. So, employee has a employee ID and whether or not they're current. Now, what I wanted to show here was the ability to override functions. Remember I said that everything in C#, every object derives by default from object, which has the toString method. Well, if you want to show an employee's information on the screen often, it's always a good idea to override the toString. Now, that assumes you always want to show it the same way. So I did here, because I know it's a console application, I go in here and put the things on the screen the way I want. That way I don't have to, in the program, when I go here to run intermediate tasks, I don't have to go crazy with console.writeLines. I can do it right here, just call the toString method and it'll do it for me. So what we do is, you remember the string builder, it's not new. We say if it's a current employee and they have a heartbeat, then we say the employee is, and this is all not new either. You can look at how we're doing it. This is an if-else. So it says if these two conditions are true, then do this. Otherwise, if this condition is false and their heart is beating, they're not a current employee, do this. Otherwise what? They must be expired. And then we just return that sb.toString because we're, see that? And notice the override word because we overrode the function. And just to show you, when you do the override, if I hit, let me go to the end here. I hit the space bar, it tells me which one I can override. You can do equals and toString. And this is where DevExpress works against me. There we go. Okay, so that is that. Now, what do we expect to happen when we create an employee? When we create an employee, what we expect to happen is a constructor to run, right? The constructor is going to run, and then that is going to call the person constructor because we told it to. So if we go up here, the person constructor, creating a new person, creating a new person. I put that so the console we can see what's going on. And then the person's going to do what? Run its constructor and then create a new human. I did it a little different just so you could see a different way of doing it. Alright, so let's go in here and do it. Let's go see what's going on. And I'll show you another thing I did. My apologies. There's a function in here. You can click this drop down to find it. If you're using Visual Studio 12, you can also go here. One thing I love about Visual Studio 12 is that you can go expand that and see that, which is pretty neat. And you'll notice there's a function here, execute intermediate methods, and that is static. And what that means is there's only, no matter how many intermediate topic classes you have in your program, there's only one instance of this function. When we get into lists, I'll show you that to you in more detail, but for now just take my word. So we're going to create a new employee. I'm going to capitalize that just because I'm picky. We create the employee. What's this going to do? It's going to create a person and a human too. We send it as an employee named Dean who's 21 years old with an ID of H05 and their heart is beating. Or I'm sorry, they're active, not their heart is beating. They're active. Because if they're an employee, we assume that their heart is beating. Probably not a good assumption, but that's okay. And then we're just going to put up who they are. We expect the 21 and all of this to come out. And then we're going to celebrate a birth date. So we expect the age to change to 22. And then we're going to put that out. And then we're going to say the employee leaves. So we expect the string in our, if we go down here to our override method, we expect it to say that they were a former employee now because they are not a current employee, but they do have a heartbeat. And then we're going to put that out, and then we're going to, unfortunately, pass. The human passes, and so we're going to put that out where it'll say, unfortunately, the human passes. Now, the other thing I'll put here, just so you could tinker with it, is you can declare class human H. Remember, I said this thing was a tree, with human being the base, person being the middle, and employee being the top. So I wanted to show you, if you created a new human, you can't do h.employeeID. It doesn't have it. Because human doesn't inherit employee. Employee inherits human. It runs one way in this case. But you can use human by itself. Heart is beating, right? You can use person by itself too. I could have gone in here and done person P equal new person. And then I could have done P dot, P dot. Notice you get name is taxable and heart is beating. You get everything the human has. But you don't get employee ID or anything from employee. I think I've beaten that one to death, so we're good, right? Alright, so there we go. Okay, so I'm going to run it. And you see it, there we go. We create a new employee. What do we expect that to do? It creates all of its base classes, human and person. And we load it up. We say, look, the current employee Dean, there's my ID. I'm 21 years old. Next thing we did was celebrate a birth date. So we expect it to do the same thing, but show I'm 22. That makes sense. And then what do we do? Well, Dean left the company. So it says former employee because this came from our overridden toString method. Everything's the same. And then we've set the expire human function. And we see that right through the employee we get access to it. And I'm no longer there. And then when I did human, it says creating a new human. It didn't create the other classes, just the human. So hopefully this helps. If you have any other questions, be sure to email me, or you can send messages through my YouTube channel. We'll be doing probably another video this weekend where we'll do some other things with functions within classes, some more advanced class activities we can do. But this should give you the basics to get you started tinkering around. Thanks a lot.